Hello and welcome to JWSOLARUSA. Here at the command center today, I'm going to show you the project I'm working on, and I did a sneak peek at some point on one of the videos, but this is what I'm dealing with. This is a 5 kVA Vevor 5 kVA 48 volts with a lithium iron phosphate Winston lithium iron phosphate, which is each of these guy is a 40 amps on each battery at 3.2. So we have them for 48 volt. So it would have been, this is a 24 volt right here. 1, 2, 3, 4, 5, 6, 7, 8, and another 8 here. What I've done, I implement or utilize the Volkswagen e-Golf bus bars to use as a jumpers interconnect. So I use one of the other bus bar to get a series here for the 24 volt to 48 volts. So it's a 16S 1P. It's just a 16S. So it's all in 40 amp. And we have the disconnect here made by SANTAN. I've done a video of this before. You've seen that on my 6048 Mppt solar, and we're using that, and we're going to use this one for the solar, which is a LONQ 40 amp for the solar. So the PV right here can go up to about 1000 volt. So let's open to this, and that's over there is the AC input, or we can able to use it as an AC output as well. So I already removed the screws. I've done some work here, and this is the inside. It ties to the positive right here, and the negative, we just assume that this is the black one, so we use a white cable. So here is the PV, the AC in, AC out. If you can see on the corner right here, the AC in, AC out, 230 volts. These are international. I'm building this system for someone overseas, some of my clients, and you can see down here is a 5 kVA 48 volt 87 amps. At least that's what excuse me, the battery supposed to be required. And here is a communication port. The last time I didn't mention that. And here is the solar input. See the PV. So don't try to mistake that. See, the bottom one supposed to be the output. The top one, look at the little arrow goes all the way here. It tells you goes here, and this one comes all the way to this bus right here, and it has a breaker right here. So live at the command center of JWSOLARUSA, guys, this is what I'm doing here, and I already got the system all set up here. And sorry, because I gotta stop because I have a phone call. Then when I came back, I forgot to turn the camera on. That this is what I was doing. I was filming, and I forgot. Then I just finished up the work, and without you guys, but I'll explain what I did or what I've done here right at the command center of JWSOLARUSA. I already get the batteries hooked up here, and positive negatives are 48 volts, 40 amp hours total. And I get them hooked up to the terminal right there. The negative, we use the white here, and the positive with the red. And we brought it in here. We brought it in here from the battery cables. It's a 2 AWG copper wire. Comes in here The positive is parallel or perpendicular to each other, parallel to each other. The red here is here. I put a black tape that goes through this white, and I'm just a test. I don't want you to discredit me for the wire coordination or whatever, wire coding. But I'm going to show you the first time we're going to fire up this inverter, and we're going to try to charge this battery again. But I'm going to do the settings here and trying to make sure that the Vevor is all programmed for the lithium iron phosphate with the voltage that's supposed to be, the range specifications. So I'm going to read before firing up the inverter. I'm turning the meter right here, and we're gonna try and test the voltage of the battery. What's the voltage, current voltage? Let's see. I'll pass this wire. Then I already have the transformer here. Since we don't have any equipment that runs in international, and you see we use a step down, a step up or step down transformer with a 7-star. Is a TC 5000G 7-star. So it has a breaker right here, and you see it's 230 volts, 50 hertz, and 3000 amps. But you will see 3000 amps. But if you look at the breaker here, is a current 50 amps. So I think it's a surge. So it has handles here you can pick up from this guy, hold it up and lift it up. It's heavy. It's a transformer here. So now we gotta change this guy here and remove from now 120 coming in. So we want a 230 or 240 because the thing is a 230. So we can able to put it right here or this way in here, the jumper, and it's gonna give us to 120. Though it's we probably just use the 220 right here and plug it right here, and the output now to the the transformer is gonna be 120 volts. We're gonna test our equipment that we want to do, and again I put the probes. It's about 53.818. So the probes are already tied up here, and see. For those of you guys internationally, you understand this. For some of us in North America, and they found it sometimes very difficult. So this is a 230 volt inverter. Like I said earlier, you see right there. Okay, that's the breaker, and it's a 48 volt 5 kVA. A 5 kVA is equivalent to 4,000 watts inverter. A 5 kVA, sometimes you have 5 volt amp. So this is the difference. It's a 5 kVA right there, and here is the output and input. So we want to charge. We use this terminals right here. So we had here the ground is the first one, and this line and neutral or hot and neutral. So if you say line, so the ground wire is always the first one, and this is the output here. So since this is the input, did you see that? So input is the top. Look at the wire, the arrow, the line continue the diagram, and this one comes the output for this other thing down here. So if we put the output right here, and we had this one, we cut this thing here. I had this already plugged in before into 120. So if I remove this side here, the crimper, I can just attach it. So the power coming off from the inverter is coming to the transformer, and the transformer output here is going to go to 120 North America, which is I'm here at the United States. Okay, so we're going to have the power out here for 220. You can able to get a 220 right here, but we already turned the regulator from the back. The input voltage that is going to be getting, so is at 220 volts. So that's the closest one, and from this wire out here to the transformer and this is the voltage we're expecting right now. The solar side is not done. I'm not gonna talk about this yet till the solar comes. I decided to put this disconnect here. Like for outputs, I can take maybe the output from here, or maybe from here if I'm using the transformer step down. The power out here, I can bring it to this distribution box, so I can able to have a termination as a main breaker. But this is just not a big one, so we can able to get a power, or maybe the generator comes here, or the AC input from the generator feeds in there. From there, it comes to the input to here. Then that's how we charge the battery, so that we can have solar as different. It has a lot of disconnect, breaking and disconnecting. That's a lot. So let's see, for the first time, let's initialize the system. The breaker is on an off position, so I'm gonna throw it all the way up, and this thing is gonna beep, and all of a sudden then it's gonna fire it up. You see the power, and we have the I was gonna keep an eye into the voltmeter here, but let's see if it's possible. Set it up here, if the camera can pick it up. So by turning up this breaker at the same time, I want you to see 5, 4, 3, 2. Okay, the breaker is up, but we have to turn this guy down here. No spark, no smoke, no nothing, and we gonna fire it up. This one here, let me show you the meter and that. The fan kicks in a little bit, boom, then it stops. And that's it. I've seen the other ones, they rave for a while. Maybe this is just a 5 kilowatt or 5 kVA. There you go. The power is on now. It's bringing a 230 volts. And the fans are not even running. It's a thermal control. When they feel the temperature, then it kicks the power. So since, like I was saying earlier, this is the output down here, AC out. So we can touch these probes right from the bottom or the top. So like I said, it's a live and neutral, or line and neutral, whatever you want to call it, for your own location. Then let's see. Oh, I gotta change this to AC. Sorry. Look at that. 227. It's on. It says 230 right there. 227 on the fluke meter. So if you try to do a polarity, a reverse polarity, say, okay, the black here or whatever, some people say it's not red, it's not a positive or whatever, it's still gonna read. It doesn't matter. Yeah, so let's read the voltage for the batteries from here. So now we gotta change. Sorry, I gotta put the camera down and change the switch to DC. So 53 volts or 52.99. Wow, it works. So now what I do for me to test anything, I can cut this wire from the transformer and get it here. It's gonna step it down. This one is a high frequency inverter, and this is now is a low frequency. It has a huge third transformer in there, so I can able to give this. But any equipment I have right now, this is live. See, some people are worried about the power factor, or they're worried about, oh, let's do the power factor. Some people worried about the the standby load. They worry about the standby load all the time, how many watts this thing is taking. But look at the fans are not running like the MPP 6048 MT. The fans are running. So this one is a continuous power. It's not like anything that is doing a thing right now, like being in a power saving mode. Let's see if it's on a power saving mode. Okay, the output is here. I might keep. Okay. Oh, I gotta put on AC. That's why it wasn't reading. Duh. So it's not on a power saving mode. It's still producing power. Here is for the solar. You see the PV right there? So the input is a 145. This is not like a 500 volts. These are 145. It says it's got a max of 60 amps. So guys, everything works. Now we're gonna come here and change the configuration and program that. I don't know if the battery monitor or capacity meter right here is actually correct. I don't know. So stay tuned for part 2 coming up live here at the channel JW Solar USA. This is what I am doing. So I hope you like that. Want to make the video nice and sweet and try to go through all the specifications and everything what I've done. I want you to understand it, and if you don't understand, replay the video. If I talk too fast, now play it again, rewind it and watch it over again and over again, then you get the joke. And from there, feel free to share the video to your loved ones, your friends, or you can do the same thing I've done here. This is set up for overseas. This is not for the United States because we don't run this kind of voltage here. Well, I know how it works, so don't worry about it. And this is what it is. JW Solar USA live from Minnesota. Alright guys, this is part 2 of the video. So I decided to mimic the power. Like this is the, let me say this is the international. So we have 120 volts here, which is North America. So it came through the transformer here, and I changed the input of that back here to 110 volt, and it gives out the power right here to 230 volts or 220. And I sent the power all the way here to the inputs by using ferrules. I make sure I put the ferrules on the cable with this ferrule crimper, and so I can just, so the tiny copper wires can be falling apart. And I have the ferrules here, all kind of ferrules. So bring the input here, and right now we'll put it in over 2,000 some watts in at 12 amps, 234 volt times 12 gives you 2,000 some watt. So here the fans are very quiet. So all the humming you can hear from the background is coming from this guy right here, the transformer. So I mimic it like a 230 volt, like I'm international, and to charge the batteries here at 48 volts. That's what I did. And now the fans already quit. You know, I think they just, so I haven't set the parameters yet and all that stuff. I just want to show you guys. So there's nothing there. And let's see the batteries. Yeah, so the batteries I see they're 54.5. That's the default. So that's why I didn't go further the charge. So this is part 2 of the video, and this is how I mimic the power to charge this battery at 230 volts using a step up step down transformer made by 7-star TC 5000G. Okay, and this is what I've done. And this is the breaker, main breaker, and this is for the solar. And right away here in here with these wires, It's a 16 gauge wire, extension cord. I think it's a 16 or 18, whatever. I think it's a 16. Then I put ferrules on this one, which is the input, and the output is here. That gives you the 230. Okay, let me put the probes here so you can believe, or you can see what I just see is believing, you know, for people, other people. So okay, let me check AC here, not DC. So I just want to tell you that it works. Look at that. That's the output right now. Okay, that's the output, the AC side. So now the batteries stop charging, and the fans are not running at all, and they're very quiet. So I haven't set up all the doing the settings yet, but there's a default, like a input of 244 and output 244. And when it was charging, you can see this little battery thing, power is going up and down. So that's what it is. All right, take care, guys. This is another video for you guys want to learn, or you guys are worried about stepping up or stepping down. I would not recommend this method because it's a transformer outside the output. So this guy runs constantly, like as you can hear it. He's a honk. He's just like, so he's taking the power. So even if your loads are off and this transformer is still plugged in, I kid you not, this guy is the one that's going to be eating all the power from this battery. It depends. If you have a big battery bank, you don't worry about it. But do not go from the inverter and you step it down to a transformer or step it up. You're losing efficiency. It's not a good thing. There's a big, like a third transformer, something like that. It's a big thing. It's huge. So I would not recommend that unless you get those kind of batteries. If you want a 120 inverter, why didn't you just buy 120 volt or 120 240 split phase inverter, or just 120, or buy 230 instead of wiring your house to another different way and use a transformer? That's a bad way to go. Okay, that's just my opinion, and that's my idea. Think I want to share with you guys. But all the same, like and subscribe. JWSOLAR USA. Thanks for watching. Let's turn off the transformer. All that beep beep noise, I'm going to be taking off that from the settings here. I'm going to shut it off. No more silence it. So you can hear the tick 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 sound. So you monitor when it started building up heat, then the fan started running. So we can use the solar from here and out. It goes in here. Then it's going to charge on solar. So I know the inverter, it works. Like and subscribe. JWSOLAR USA, live from Minnesota.